Okay, so in this video, we want to review a basic property of exponents, which is in this case that x to the m divided by x to the n is equal to. So the question is, if we divide two exponents that have the same base, can we regroup under a same base, under a single base? The answer is yes, and it is obtained simply by subtracting n from m. So x to the m over x to the n is x to the m minus n. Now there's a second way of looking at this. Now here we kept the x on the numerator, so if that's the case, then we leave x here and we say, well, this will be x to the m minus n, but we could also choose, for whatever reason, that we want the x on the denominator. Now if that's the case, this will become x to the n minus m. So wherever you choose to leave the x either on the numerator or denominator, in this case, x to the m minus n is our final answer. Here it's x to the n minus m. And of course, these are the same. If you remember, when you send an x down or up, you simply get the reciprocal, which is the same as negating the exponent. So if you send the x down here back up, this will be x to the negative of the exponent, so negative of n minus m. And if you distribute, of course, you get x to the negative n, negative negative plus m. And if you swap the order, you get x to the m minus n, just as before. And as I've said, you might choose to take this expression or this one depending on what you want to do with it after. So whenever you have a quotient with the same base and different exponents, you can combine as a single power of x, either leaving x on the numerator or on the denominator. Let's look at a simple example so that if you ever forget this rule, you can easily derive it. So what if we had, say, x cubed over x5? So naturally we can first expand both numerator and denominator. So x cubed by definition is x times x times x. X to the 5 is x times x times x times x times x. And then we have 3 x's on top, 5 on the bottom, and because these are products, we can cancel common factors. So we have an x here and an x here, we can cancel them. Another pair of x's, we can cancel again. Another pair of x's, we can cancel again. And what are we left with? Well, naturally, on the numerator we've canceled everything. We are left therefore with a 1 over, on the bottom, xx, which of course can be rewritten more nicely as simply x squared. So we have that x cubed over x5 is 1 over x squared. And again we ask, well, how do we obtain 2 from 5 and 3? Well, using this rule. If you have a quotient of 2 powers of x, and you want to keep x on the denominator, the power on the bottom stays there, so the 5 stays there, and then you subtract the power from the numerator, and of course 5 minus 3 is 2. We could of course choose to leave x on the numerator, so x cubed over x5, and if we choose x on the numerator, then if we go back up, the 3 stays on the x, and we subtract the other exponent, so 3 minus 5. 3 minus 5 is negative 2, and of course these are the same answers because if you send an x from the numerator down to the denominator, you negate the exponent. And the negative of negative 2 is, of course, positive 2. And that's it.